All right, moving on to 12.3 in Module 12. This section helps prepare us for addition and subtraction of rational expressions. The first problem here says to find the least common denominator. So that cues us into that, hey, we're only going to look at the denominator in this problem. And so what you want to think about, and we've been doing this a lot this chapter, is that we have to factor to get started here. And so I'm going to factor this into x plus 8 and x plus 4. Okay. And what you want to remember about the LCD here is you want to remember that all binomials, all monomials need to be represented. So I spot, hey, this is the binomial x minus 3, so it needs to be represented. X plus 8 is a binomial that's in the denominator, and x plus 4 is a binomial that's in the denominator. So I get this long string that is my LCD here. And we don't have to multiply that out. That's just it. It's just a process, and that's it. Don't make much sense of it, but that is the LCD, okay, the least common denominator, okay? Now looking at this next one, again, we have to factor things, okay? So I'm going to factor this into 2x and x. I'm going to put plus 5 here, I'm thinking ahead, and plus 2 here, because 5 times 2 is 10, and if you check this, that would be 4x and 5x, so that makes the 9x, okay? So factoring sometimes is difficult, you just have to work with it, all right? This is 5x and x, and I'm going to use 4 and 7, and trust me, it works. 20 and 7, it works. Now, these two problems maybe aren't the best examples for LCD, but they work, all right? You just have to remember that every binomial needs to be represented in the LCD, and so we have to actually write down all 4 of them here, okay? So that is the LCD, all right? So just make sure to write all the pieces down, all right? So maybe these will come out a little bit different here, but we find the LCM of this polynomial here, or these two polynomials. So it's basically the same thing we were doing for LCD, but we just don't have denominators, okay? So this is z minus 3. I make my z's with a little cross through them, or else they look like 2's. So I have z minus 2. And then this is z and z. And I have minus 5 and minus 2. Okay? I see my 2's look a lot like z's. Okay. So if I want to make the LCM here, remember, all binomials must be represented. So I have to have a z minus 3. Got it. I have to have a z minus 2. Got it. And I have to have a z minus 5. Got it. Okay? And I have to have a z minus 2. Well, I already got it. Okay? There is my LCM. So see how that was a little different than the first couple there. Okay? And then here, this one's a teeny bit tricky. They always are a little bit with the negative signs, but you know, just take your time with it and think, okay, it has something to do with -1, because we've been working with this throughout the chapter or the module. So let's get these in the same order. So this is already in z minus 6. I like the z up front. If I change this to -z plus 6, remember that's the -z, positive 6, and then factor out a negative, I have z minus 6. Okay, so this will help us get to the LCM. If I have an LCM, I have to have all monomials and all binomials represented. And if there was trinomials, etc., I'd have to have those represented. So this is a piece of the LCM. It's a -1. So it's negative, and then we have to have the binomial z minus 6 represented. So there's we have the binomial z minus 6 represented, and we have the negative sign represented. Okay. Let's just finish these last 3 problems here, and that wraps up 12.3, and we'll just have one video from 12.3. If you need more examples, just email me, okay? So it says find the missing numerator. We have to kind of ask ourselves, how do we get from here over to here in the denominator? Well, we had the 2x plus 7 over here, right? The new piece was multiplied by 6, so I multiplied by 6. Well, I just take this times 6, and I get 48. Okay. So then again on this one, we say, okay, what are the new pieces? Well, how did I get from 2 to 16? I took it times 8, right? Then also I had this x minus 4, right? That was present on both sides, but I also took it times x plus 4. That was the new piece. All right. So I need to take this numerator times 8x plus 4. And I could write that out as 64x plus 4, quantity x plus 4, like that. Or if I felt like I needed to multiply that out, I could do the distributive property. I kind of like it just left in the factored form. Okay. And then the last one here, and you hopefully you're looking at these and you're saying, wow, that's not too bad. But you can get yourself a little confused and just email me or ask me for some more examples. Okay. So here you can spot this is present in both of these, and this is the new part right here, the times y minus 9. So to get from here over to here, we took it times y minus 9. So I'm going to take this times y minus 9. So it's 2 binomials multiplied together, so I'm going to put the parenthesis around there. And then hopefully you remember that this is conjugate pairs. So if you didn't, you would just FOIL this, okay? I suppose you could write your answer as y plus 9, y minus 9, all right? But if you started to type that in and it says the parenthesis isn't accepted, or they said write this out in standard form, you would need to multiply this together, and so you would get y squared, and then remember the middle terms cancel out, so we'd have minus 81. That's what we get from our conjugate pairs. Okay, so this process is going to help us add and subtract rational expressions, which is a little bit tricky for a lot of students, but just take your time and make the common denominator, and hopefully we can get through that okay. All right, thanks. That wraps up 12.3. We'll get a video together for 12.4.